Great doctors. Today is the 24th of June 2017, and here we are for another seminar. We are going to be having part analysis today, and there will be some very interesting presentations from a number of us. We're going to kick off with Madam Omoraka Faith, and I've looked through the slides. They are very, very good. I'm sure we're going to have a wonderful time today. So let us get our slide. Let's see where the slide is. Yes, I have the slide here. Okay, so can we now yield to Madam Omoraka Faith to make her presentation? Over to you, Madam.
Okay. Good evening, sir.
Good evening.
Good evening, madam. Good evening. This evening, I'm presenting on fact analysis. Quickly, let's go to slide 2. Fact analysis is a form of multiple regression statistical analysis used to evaluate causal models by examining the relationship between a dependent variable and two or more independent variables. On slide 3, you can see that fact analysis also includes models equivalent to any form of multiple regression analysis, factor analysis, canonical correlation analysis, discriminant analysis, as well as more general families of models in the multivariate analysis of variance and covariance analysis.
Very
These
good.
are the MANOVA, and AMPA.
Excellent.
Slide 4 gives us a brief history of fact analysis, and here we are told it was developed in 1918 by Sewell Wright. And Sewell Wright used this method so as to enable us to estimate both the magnitude and significance of causal connections between variables.
Correct.
Slide 5 tells us that fact analysis has been applied to areas of complex modeling, including physical sciences, social sciences, and sociology. Quickly on slide 6, we want to see the rules for tracing paths. Now, the rules of tracing paths include that you can trace backward up an arrow and then forward along the text, or forward from one variable to the other, but never forward and then back. You can also pass through each variable only once in a given chain of paths. Also note that no more than one bidirectional arrow can be included in each path chain. Slide 7 gives us a graphical picture of what I've been explaining about path tracing rules. Now, on slide 8, we want to see what we use path analysis for. Now, path analysis enables us to measure the indirect and direct effects that one variable has upon the other. We also use it to describe expected dependencies among a set of variables. Path analysis can also be used for both bivariate and multiple linear regression techniques to test the causal relations among the variables specified in the model. Slide 9, we are looking at assumptions of path analysis. Thank you, sir. On slide 9, we are looking at assumptions of path analysis. One is linearity. This means that the relationship among the variables must be linear. Then we have the interval level data. Data should be dichotomous. Data should be dichotomous nominal, that is, regularly dividing by pairs from the bottom. Then we have multicollinearity. Low multicollinearity is assumed. Perfect multicollinearity may cause problems in the path analysis. Then we have identification, which states that your variables should be properly identified. They can be under-identified. They can also be over-identified. But the most important thing is that we should see them in your path. Then the last one, which is adequate sample size, means that your variable should be adequate. It should not exceed, it should not be less than 200. Then on slide 10,
Go ahead. Good.
path analysis using AMOS. AMOS is a statistical application that is used for path analysis, and it simply means analysis of moment structures. It is an easy-to-use program for visual structural equation modeling. Amos simply specified the hypothesized model graphically. On slide 10, on slide 11, sorry, we want to look at an example. We are looking at a study, and this study is on a path analysis on factors predicting the achievement of third-year undergraduate students in Lagos State University, Ojo. I decided to use the data for our exams.
Okay.
And first of all, when you are using Amos, the first thing you do, you have to conduct a multiple regression.
Are you taking us to the next slide? Are you taking us to another slide?
Yes, slide 12, please.
You didn't tell us. Okay.
I'm sorry.
No
On
problem.
slide 12, the first thing we should do is to input multiple regression data into SPSS. SPSS is also a package, which means statistical package for the social sciences. On slide 13, after you have imported your data into SPSS, the next thing you should do is to launch Amos. You can see on slide 13, when you launch Amos, this is the first thing you see. Now, slide 13 shows you Amos as it is. On that same slide 13, you see that Amos has different tools that you can use to do your prediction. Slide 14, you use your draw observe variable to draw boxes for your variables. Slide 15 shows you what you get after drawing your your boxes for your variables. Then on slide 17, you upload your data from SPSS. That's what you can see there. You can see a graphic image of that on that slide. Then slide.
Yes, go ahead.
Slide 18. On my slide 18, you can see that. I'm sorry, I missed a slide.
No problem. So which slide do you want to get onto now?
Slide 16, sorry. Slide 16, you use the single-ended arrow tool to connect your variable boxes as you have predicted them. Then slide 17, you upload your data from SPSS. Sorry. 18, you use the list variable in data tool to label your boxes according to their variables and predicted links. Slide 19, after labeling, this is what we have. You can see achievement post, you can see the dependent variable and the independent variable connected to it. Then slide 20, you have to put your error terms, and you do this by using the draw observe variable, then you give it a variable name. After this, you have to make sure that you draw an arrow to connect your error term to the boxes. You do this by using the single-headed arrow tool. Then after that, you label them, giving them a regression weight of 1. Then on slide 21,
yes,
we have the hypothesized path model. And you can view the hypothesized path model by using the input path diagram tool. Now, from my model, path 21 gives us the result. And the result is saying that there is a relation, the result is showing us the dependent variable and the independent variable, which is on slide 22. 23, from the model, it was predicted that there is a direct link from group, like method, future scientists, practical pre, attitude post, achievement pre, and school location. Slide 24 is showing the hypothesized model, stating that there is an indirect link between sex to group to achievement post. There's an indirect link between socioeconomic status to school location to achievement post. There's also an indirect link between practical post, practical pre to achievement post. There's also an indirect link between attitude pre to practical pre to achievement post. But that is not the end. We have to continue because we are using Amos. What I just explained now is the hypothesized path model.
Good.
Now we need to get to the final path model.
Yes.
And so we'll continue by going to slide 25.
Good.
Now, slide 25, by continuing, we have to click on analysis properties. When you click on that tool, a dialog box will appear. Then on estimates, you tick maximum likelihood. Then you also tick estimate means and intercept. Then on that same dialog box, on slide 26,
Yes.
you also go to outputs. Then you tick minimization history, standardized estimate, squared multiple correlations, sample moment, indirect, direct, and total effect, factor score weight, and covariances of estimates. After you must have done that, you close your dialog box. Then you go to slide 27.
Good.
Slide 27, you click on your calculate estimate tool. When you do that, you see a dialog box will appear. This dialog box will ask you a question. Do you want to proceed with the analysis or you want to cancel the analysis? This question comes up because there are some dependent variables that have a little problem. Amos wants to see if you can correct them. It's a warning. But never mind, just click on proceed with the analysis. And when you proceed with the analysis, on slide 28, you now see, you go to the view output path diagram, and then we have our final path model, which you can see on slide 28. Now, from this study, I was able to conclude using Amos on slide 29, the final path model presented by Amos as shown on slide 28 shows that like method is the most potent variable in predicting the achievement of third-year undergraduate students with a beta weight of -0.04. Therefore, I would recommend that student preferences in method of teaching should be considered by teachers and academicians. Thank you very much. On that one, we have my references. God bless you, everybody.
Wow. Yeah, you can't cease to amaze us. Your presentation was quite awesome. While I was in Paris, I'm actually reaching the class from Abeokuta now, and that's the Lucia Obasanjo Presidential Library. And it's, I mean, true to type, you are just leading. I'm just quite impressed with your presentation. Very sequential, very efficient, and very clear. Very clear. Wonderful. Well done. Well done. So you had the applause from members of your class. It shows that you've done very well.
Thank you.
So let us now take on the questions and observations, and I will go from my panel here. I'll go from my right to the left. Madam Fumlayo, I know you start, and then Miro Lagunju will be next. Ibrahim Alabi will be next. Let's take the first three. Yes, Madam, I know.
Okay, sir. I only observed that there are some words that are joined together in slide 22 and 23, sir.
Okay, slides 22 and 23.
Yes, sir.
Yeah, 22 and 23. Some words are joined together. I thought you should know that. You don't need to ask that question, no, Madam, I know. The achievement post. That's the name for that variable. So it has to be joined together, because if you're working with SPSS and you are going to get a variable name, it do not allow you to put all manner of things that you have to condense. I think 8 characters or something. They have to be condensed. Madam Faith, have I helped you out there?
Yes, sir. Yes, sir. That's it.
Yeah. So you don't need to.
If you add too much characters, SPSS will decline it. So
Will
you have
decline
to
it.
make sure that you try to.
Exactly.
I understand. You did not put space.
No, you don't put space
Okay.
now. That's what she's telling you.
That's I think.
Very interesting. Don't worry, Madam. I know you will. I think outside class you will get to have a feel of that. Yes. Madam Olayanju, Dr. Olayanju Mary. Ibrahim Alabi,
Yes,
next person.
Yes, sir.
No, we've gone past you.
Good evening,
Ibrahim
sir.
Alabi, yes.
Good
What's your
evening, sir.
question?
Good
Yes.
evening, sir. So, slide 24.
Slide 24.
Yes, sir. I observed that the dependent variables are part of independent variables when it is being listed. That's slide 24.
Sorry,
So, like attitude pre-test, attitude post-test, achievement pre-test. So all these are the dependent variables. So is it listed among independent variables, sir?
Okay, let her make a note of that question if she understands it. So we've taken Alabi. Now I'm going to take Lanre, Fakunle, and Peter in that order. Lanre,
Yes, sir. Slide 6.
slide 6,
My
yes.
question is on the third bullet there that says no more than one bidirectional arrow. I want to know what the bidirectional means because on my path, on my Amos application,
Yes.
there are two arrows there. There is one single-headed arrows and the
Yes.
other one is double-headed arrow.
Yes, that's correct. Okay, so make a note of that, madam.
Does she have directional?
Okay, she has made a note of that, I'm sure, and she will give us a good response. Yes, Peter. Okay, Gbeleyi.
Yes, sir. Thank you very much, sir.
Yes.
My question is on slide 9.
Slide 9.
Are we there?
We're almost there. Yes, I'm there though. Yes.
When she was explaining about adequate sample size, she
Okay.
said less than 20. I want to ask if you have less than 200, sorry.
Yes.
If you have up to 200 or more than, what is the situation going to be? Thank you.
Okay then. So Johnson, that's the last.
Yes, sir.
Sorry, I cannot hear you. Maybe others are.
I think someone is saying Fakunle is supposed to.
Faculty is supposed to do what?
Someone was saying that Fakunle has not responded before you called me.
What's your business with that?
Oh,
Okay, now that's all right. Madam Mary, Madam Omoraka Faith, please answer the questions that you already have. Yes.
Okay, Dr. Alabi, I want you to understand that in this study, achievement post is the dependent variable.
That's correct.
I know you are already used to this data and you are used to the fact that we have attitude post and then
practical skills post. That's
and
true.
dependent variable. But as far as this study is concerned, achievement posts are dependent variable.
Good.
I hope you get that, sir.
Good.
that's good. That's good.
Yes.
Then Dr. Larry, you talk about bidirectional arrow. Now, this means that when you are when you are drawing your arrows, please, it shouldn't be more than two. When you are connecting one variable to the other, let's assume you want to connect school location to achievement post. After doing that, you should not connect school location to attitude post and still connect it again to achievement post. I hope you got that, sir.
Yes, sir. Yes, my dear.
Then Dr. Gbeleyi, I want you to understand that according to Klein 1998, it was not said by me, Klein 1998 said it. It said we should make sure that the list of variables should not be more than 200.
No, not the list of variables, not the list of variables. Maybe the end of cases, number of records, number of subjects that you are putting in there. Not the list of variables.
Oh, cases. Sorry, cases.
Exactly.
Cases. Yes, I got it now. Thank you, sir.
All right. Wonderful. You have answered the question so very well, and you are deeply appreciated. Let us appreciate her again for a job very well done. Okay, now we take on Ibrahim Abiola Alabi, one of our one of our star doctors in this class. So Ibrahim, you have the floor for your own angle to path analysis.
You're welcome. Good evening, sir. I'm Abiola. I will be presenting on path analysis. So let's quickly go to slide 1. Introduction. Introduction here is telling us about.
Can you speak out a little bit louder?
Genetics in 1918.
Can you speak out a little bit louder?
That developed the path analysis.
Can you speak out?
Sentence survey, slide 2.
Yes, go on.
So, path analysis gained popularity in 1960 when Blacklock, Duncan, and others introduced it to social science. So, on slide 3, sir, the development of this general linear model by generals and others in 1970. Today, one can conduct path analysis with a statistical including SPS on slide 4. What is path analysis? Path analysis is a form of multiple regression statistical analysis used to evaluate classical model by examining the relationship between dependent variables and some more independent variables. 5. What does path analysis intend to do? As we all know that path analysis is a straightforward extension of multiple regression. So what it aims to do is to estimate the magnitude and significance of hypothesized causal connection between sets of variables. So that's the basic thing it intends to do. Just to estimate the magnitude and the significance of hypothesized causal connection between a set of variables. On slide 6, we're making a relation with path analysis and structural equation models. Path analysis is a special case of structural equation models. While structural equation model use latent variables to account of measurement error, path analysis contains only observed variables, and each variable only has one indicator. While under a structural equation model, most of the models can be equation are structural equation model. Then path analysis assumes that all variables are measured without error. But on the part of structural equation model, it has a less restrictive set of assumptions than path analysis. We want to slide 7. The key components of path analysis. 1. Path diagram. The composition of covariance and correlations. Direct, indirect, and total effect. Slide 8. Slide 8 is telling us about the basic features of path analysis. We have model specification and identification. We have model estimation. We have model fit. We have model modification and re-estimation. We have final model parameter interpretation. We move on to slide 9. The basic requirement for path analysis. 1. All causal relation between variables must go in one direction. That is, they must be in one direction. That is number 1 requirement. Then the second requirement is that the variable must have a clear time order. This one variable cannot be said to cause another unless it will see in a time. So we go on to slide 10. The key assumption of path analysis. 1. All relations are linear and additive. 2. The residue, error times, are uncorrelated with the variables in model and with each other. 3. The causal flow in one direction, in one way. Therefore, the variables are measured on the interval scale. 5. The variables are measured without error. So these are the assumptions we have to consider before going on to path analysis. We move on to slide 8. Sorry.
Yeah. Just go on.
Slide 11.
Yes. Alabi, we are waiting.
So on slide 13, I want to
Yes.
on tuition scientist and lab method. So I want to know which one have a direct effect on achievement test. They have a positive effect such that they improve student performance in academics. So this is an example of analysis in academic setup. So now the first thing I will do is that I should understand that in considering these independent variables, which are visual scientists and lab method, there are also other independent variables that have influence on independent variables, such as group sex, socioeconomic status, among others. We move on to slide 14. Slide 14 is telling us the step we have to take in model. So the first thing is for us to formulate hypothesized model. Having done that, we try to know if the model is identified. We go on to estimate this model. Then we ask ourselves, did algorithm converge? Our estimate stable? All these we have to put into consideration before we go into path analysis model. Then does model have good fit? All this, when you consider it, before you now conclude, or you have to interpret your results. So we'll move on to slide 15. Slide 15 thing is telling us of how to use path analysis. Simple path analysis involves the construction of a path diagram in which the relation between all variables and causal direction between them are specifically laid out. So the first thing we must do is to construct an input path diagram which illustrates the hypothesized relationship. After that, we have to complete construction of the output path diagram which illustrates the relationship that exists between all these variables. So we'll move on to the next slide, slide 16, hypothesized models. Hypothesized model here is telling us that, okay, what are things you intend to do? We predict, okay, let me predict this path directly. So we hypothesize all these models. So from there, we want to see if the hypothesized model is picked up. So we go on to final model.
Yep. Yes, go on, Alabi.
Everyone is able to know if decision scientists and lab method as a direct. So our final project, we're able to report that fusion scientists, lab method, have that with achievement process. So they have a better way value of all this 1.99, 1.0, and so respectively. On the part of group, we have also indirectly. These indirect links are you group through sex, group through socioeconomic relations, socioeconomic through school location, and through the lab method. So all these are indirect links. So we also have their better way value there too. So we'll move on to slide 19.
Yes.
Slide 19 is telling us that, okay, how will you conclude? Unlike the direct link, we realize that among all the direct links, we have like method having a better or its most potent direct link achievement process of better rate of this. So we also have on the part of indirect link, we have like method most potent that indirect link within the social school location, school like method, the indirect link that exists there is the most potent one among others. I now consider these two. With the direct link and indirect link, which one is more potent? So I realized that the indirect link school to school location is more potent with the better value of minus 0.02.
Yes.
Slide 20. So conclusion. There is a lot of the analysis, but what is important to remember is the overarching principle of multivariate analysis.
Yeah.
With the use of analysis of modern structure, path analysis. So reference is in slide 21, slide 22, reference continue, slide 23, thanks for paying attention, God bless.
Yes, thank you very much. Thank you very much, Alabi, for your presentation. We'll now take questions, but before that time, let me just correct some pronunciation, just a little thing. It's called beta weight, not beta weight. Alabi, I want you to say beta weight 3 times.
Beta weight, beta weight, beta weight.
Very good. So it's not beta weight. Okay, that's a very little.
Maybe because I'm working in better class, sir.
You are working where?
Better class, maybe that's what.
Oh yes. That's good. That's good. So let's go from my left of this screen to the right. Gbileyi, what's your question for Dr. Alabi? Followed by Joseph Muidena.
My question might be straightforward to everybody that is presenting on this topic, sir.
Yes.
See, I love the fact that you are always looking at immediate trend and the future trend. So regarding this topic, I want to ask Dr. Alabi if there is any similarities between projecting or predicting results of football matches in line with part analysis. Is it possible?
Are you a gambler? Are you this coupon? You know these people who play this thing. Yeah, actually, multiple regression directly will be better in that case, and then you can use it for multiple regression to look at the pattern of play and winning of or not winning of all these all these football teams. Yeah. Okay, that's my way of a joke, but I'm sure Alabi will provide some answer. After Joseph Famuide, then there's Fakunle, then Aribi. Yes, Famuide.
Yes, sir. I would just want him to explain something on slide 20.
Yeah, what is it on slide 20?
On slide, path model simply very specific covariance structures. What do you mean by that?
Okay, what do you mean by this? Let me just highlight it here. Yeah. Okay, Fakunle.
Yes, good job, Dr. Alabi. I want to ask this question. Are there any other tools we can use for path analysis aside from Amos?
Yes, okay. Dr. Aribi Lanre. I think I saw something like Lorenzo in one of your
Yes, sir.
yeah. Is that the name you called fondly while you were in school?
sir. Yes, sir.
Are you still called Lorenzo even now?
Yes, sir.
Yeah, very nice. It sounds nice. Well, how did you derive the name? If you want to share with
It
us.
was my friend during undergraduate that derived the name.
Yeah. What is the etiology? What's the origin of that?
I think it's an Italian name for a strong person and a brave person. It means strong and brave from the Italian aspect of it.
Oh, that's fine. That's
So,
fine.
yes, sir.
Okay, that's fine. So, ask a question.
My question is on slide 14. Dr. Alabi, on your path model, a path model of path analysis steps. Yes, I like the model. When everything kick the computer. I hope we will not kick my own computer right here. But did algorithm converge? Estimate stable. I need if you can explain that more for me.
Yeah,
please.
this one.
Thank
Yeah.
you.
Okay, that's very good. Good question. Yeah. So let's see. So we're going to take on Dr. Mary Olayanju, Dr. Baraka Faith, and Dr. Fumilayo Aino in that order. So Dr. Mary Olayanju.
Yes, I would like him to go to slide 10.
Slide 10, yes.
The fourth point, the variables are measured on interval scales or better. I feel something.
I can't hear you longer, sir.
Dr. Mary Olayanju, can you slide 10?
Can you hear me now?
I can hear you,
Slide
for
10.
instance. Slide 10, number what point?
Number 4.
Okay.
The variables are measured on interval scales or better. I think something is missing there before the full stop. Or perhaps it's trying to join the fourth and the fifth point together.
Okay. Thank you, ma'am. I think we have the last person to ask. No, Dr. Baraka Faith, what's your question? You just asked somebody.
Dr. Alabi, on slide 6, path analysis by structural equation model. On path analysis, on your third point, you said path analysis assumes that all variables are measured without error. Then how come you need to draw your error terms and also label them if all variables are measured without error? Please, can you explain on that?
Very good question. So, Dr. Aino, over to you.
Sir, on slide 9. I want to know more requirements on path analysis. Basic requirements. Are they just two?
Okay.
Hello?
Yeah. Okay, that's fine.
Slide 9.
Yeah, that's fine. That's fine. We'll get a question. Okay, so Alabi, you have the floor to respond to all the questions that have been posed for you. Yes?
Thank you very much, sir. The last question, that is the basic requirement for path analysis. I also believe that you have more than this.
You can have more than basic requirement for path analysis. But at the point of the all I need to know is that the basic requirement you need to focus on. At least these two must not be out of it. You can have more than this basic requirement, but these two must not be out of it. Hello?
Okay. Yeah, that makes sense because you said basic. That's fine. I mean, basic means that all those ones must be there.
At least the primary requirement is the primary requirement. That's the meaning of
Yeah.
that basic.
Yeah,
The primary requirement.
that's it.
So you can have more than this, but this primary requirement must be part of it. Okay. Hello, madam.
Yeah, good response. Pause. Go on to the next. Go to the next.
Okay. The slide on slide 6 that path analysis assumes that all variables are mentioned without error.
That's not
If you
correct.
look at slide 6,
No, that's not correct. Yeah, that statement is not correct. That's what Dr. Moraka Faith has told you. There's nothing error. No, there must be an error term. That's why you have like standard error of measurement for anything at all. So anyway, you can adjust your statement at some point. Next question.
Mr. Fanmuide, you asked if this can be used to predict a football match.
No, that's Beleyi. Beleyi is the one that wants to win some money. Jackpot. Yes.
As I've said, that path analysis is an extension of multiple regression.
Yes.
So in multiple regression, we normally use to predict.
Yes.
So definitely you can as well use this to predict. It's an extension of multiple regression. So you can as well use this to predict any football match or anything.
Okay. That's fine. Thank you very much. Are you happy with that, Beleyi?
Yeah, yes, sir. I'm happy.
Oh, yes. Okay, let's go on. Dr. Alabi, go on.
Yes, sir. On slide, somebody else on slide 20 or so.
Yes.
Hello?
We can hear you. Go on.
Hello?
We can hear you. Okay, fine. I think we are losing him. So let's go on to the last presentation, and that is going to be by Dr. Johnson Famuyide. So, Johnson, are you set?
Hello?
Yes, sir.
Okay, that's fine. So let's try to get Famuyide's file. That will conclude our cycle of presentations on path analysis today.
Everybody.
Yes, we're on to Famuyide now. Johnson Famuyide is making his presentation on path analysis. Go ahead.
Let's quickly go to slide 2, where we have the brief history. Path analysis was developed around 1918 by Seward Wright, who wrote about it more extensively in 1920s. And this has been used severally by other scholars, and it has been used in several departments of learning: biology, psychology, sociology, economics, and so other departments of learning. Let's go to slide 3. What is path analysis? Path analysis is a straightforward extension of multiple regression. And by saying this means that this is also introducing back to what I did the last presentation, talking about
Yeah, that's true. Yeah. That's so. Your voice is very clear. By the way, Johnson, your voice is very clear and sharp. Very nice. Please go on.
Multiple regression analysis. So this is a continuation of that which we did few days back. So let's go on. And we said a special case of multiple regression where all the relationship among variables can be estimated simultaneously. That is, estimate correlations among your independent variables simultaneously, estimate regression relationship in the model, and with this, that means you can do both correlation and regression together simultaneously. Let's move to slide 4. Slide 4 is talking about the path analysis model, and we are supposed to move to slide 5. And on slide 5, we explain what slide 4 is, where we have EX1 and also called explaining variable. Let's move to slide 5, everybody. EN1 and EN2 are endogenous variable, outcome variable. And we have said E is the error. Then I said you should note the types of the effect or the link. We have direct link, and my colleague talked about the third one, the total effect. So let's go to slide 6. Slide 6 talking about path diagram conventions. That is when you are drawing a path model. There are some shapes that are very, very important for you to know. That you must not make mistake of interchanging one with the other. You say the rectangle is for the observed variable, while the circle is for the unobserved variable or the latent variable. While the arrow is talking, the single-headed arrow is talking about cursor path, while the top two-headed arrow is talking about the covariance path. Let's go to slide 7. On slide 7, we talk about path tracing rules, which Dr. Omoraka also spoke about. So I'll just say the rules of path tracing are you trace backward up an arrow and then forward along the neck, or forward from one variable to the other, but never forward and then backward. You can pass through each variable only once. Underline that only once in a given chain of path. No more than one bidirectional arrow can be included in path chain. My friend talked about the benefits of path analysis. Estimate all the relationships among all fields
Yes.
dependent variable and the independent variable. Then the second one, able to test various hypotheses regarding different relationships. Let's move to slide 9. On slide 9, there is an example there for us, and I said, draw a path analysis predicting the achievement of the student group, sex, and socio-economic status. Well, let us note this. I'm not going to go the easy way that my other colleagues went. I want us to look at doing this thing on SPSS and seeing how we can draw the path, how we can draw a path model, both hypothesized and final model in SPSS. So let's go to slide 8. We have the procedure. You draw the hypothesized model. Variables that have direct conduct correlation analysis to get the covariances or the correlations. So let's go to slide 11. Now on slide 11, you see the hypothesized model. Then on slide 12, we'll see how everything is being done to go through the multiple regression steps in SPSS from slide 12 to slide 17. It's telling us how everything, both the regression and correlation, is done on in SPSS. So let's move to slide 18. Slide 18 is talking about the important steps. And you see, just like I have stated in the procedure, I said I talked about you finding regression, multiple regression. Doing multiple regression and then doing correlation analysis. Now you will see we have correlation table, and there we will be able to find why did I put the correlation table? So that we will be able to find the covariance. The curve double-headed arrow, and then we have the model summary. From the model summary, we'll be able to use our R square. From our R square, we will be able to find the error by saying 1 minus our R square. It will give us the error, and then we have the coefficient table. The coefficient table, when we look under the standardized coefficients beta, we will be able to see that is going to stand for those direct links that we talked about. Then we move to slide 19. On slide 19, you will see what we have been able to do based on videos, and you can see how we have been able to put the beta. You will see that we got this the beta curve. We have minus 0.025. We got minus 0.025 and minus 0.038 and minus 0.162. All these ones were gotten from the results we found, from the relationship we have found out from the three, from group, sex, and social economy status. They are covariants, and that's why we are able to put their own weight there. And the other one that we have direct link achievement purpose. We got that from the regression and multiple regression analysis that we run. And that will take me to my last slide, slide 20, my reference, and slide 21. I thank you all.
All right. Wonderful. Well done, Johnson, Famoyide. Yeah, so Iroko has come in again. If he's going to make some noise, I'm going to drop him off. We'll take questions, and we can go from Dr. Aino, question, followed by Moraka Faith, followed by Mary Olayanju. Dr. Aino, from Layo.
My question is that slide 5.
Larry, there's some noise coming from your end. You may have to be dropped out of this class. Go ahead, slide 5 years.
As he was explaining the model, he said small e stands for error. But in our famous, whenever we want to analyze, we say capital E is error. Whether capital E1. So I want to know the difference. Is it the same thing or it must be strictly capital or small letter?
Very good question. Yes.
At the end of the presentation, the interpretation was not included as other
Okay. Thank you. Madam Omoraka Faith.
Thank you, Dr. Johnson. In your presentation, you said you will use SPSS to draw your hypothesized model and final path model. But I don't think that is true. It's not possible. I want to believe your example or study was by hand because you did not indicate the use of any application like Amos. Yeah. And use your multiple regression results, that is your beta weight, to get the most potent variable. You did not state that. You didn't tell us the most potent variable for your study. So can you please do a little emphasis on that?
Thank you very much. Dr. Mary Olayanju, then followed by Ibrahim Alabi. Yes, ma'am.
All right, sir. I quite appreciate the fact that
Can you speak out louder, madam? We can't hear you.
Yes, sir. I said I appreciate the fact that there are some side notes between slide 12 and slide 16 when he did the demonstration using SPSS. Out there in slide 13 and slide 16, the side notes are missing. So if a novice is handling it, is going through this slide presentation, the person, it will not be too explicit enough for the person. And also, I would just want to check up some spelling, especially there are some spelling mistakes.
There are too many spelling mistakes. Too many. Bitter way. Yeah, at our level, Johnson. Just a minute. Okay, thank you. Alabi is gone off. So Larry, I'm removing Iroko again. It's giving us some noise. Yes, go ahead. So tell Iroko, anytime we remove him from this thing, there's quiet. There's too much noise at his end. Larry, go
Yes,
ahead.
sir.
Yes.
My question is on slide 18.
Yes.
The model summary, I can see it is significant at 0.00. What if it is not significant? Should we go ahead or we should just go back to our videos?
Good. Fakule, if you can hear us.
Yeah, yes, Dr. Johnson, good work. I want to ask, what about if I have two predicted variables, two independent variables in my study? Can I use path analysis?
Yeah, I keep just a minute. What is the singular? No. What's the plural form of variable? All of you.
Variables.
Exactly. There's the S there. You hear from Muide and many of you, you say 2 variable, 10 variable. Why are you missing out the S? Very important. You are doctoral candidates, by the way. So, Bele, last one. Bele is not said. So, okay, we can't hear. Bele has some challenge with his connectivity, I think. So, it's very good job. Johnson, you're very good. Very proud of you. The only thing that I have is that you appear to be living in the old world. You know, when I was doing this part analysis, when I did it for my doctoral work, we didn't have Amos at that time. And so we had to go through this path of drawing the thing, of using multiple regression, several multiple regression analysis, not just one, several, because it's going to be testing the different links to be able to get your final model. But later, you then had the analysis of moment structures, Amos, developed that can help you. So Yorubas have this saying that how can you have a hoe, then you want to pick what is a feces, and then be using your hand to pack the feces. Larry,
Yes, sir.
can you tell me? Can you put the Yoruba form of it? Akin lokon leka fọwọ́. Do you understand that?
Yes, sir. Wait, sir.
I'm sure that Madam Moraka doesn't understand that kind of Yoruba. Do you?
Not at all, sir.
Okay, Madam Mirola, please can you explain that Yoruba saying? Akin ní ọkọ nílẹ̀ ká fi ọwọ́ kó mi.
Yes, when you have the potential to, you make use of potential to. You don't make use of. That's just the literal interpretation that you use
Yes.
the right.
Exactly.
Right
I will never. When I see somebody saying he's doing path analysis and now using multiple regression, that's fine. But there, you see, the Amos gives you a better control, gives you reduces error rates on so many of the computations, and it draws the model for you. It gives you the thing accurately. So why would somebody in this day and age, in 2017, when I did my old PhD almost like 1 million years ago, that I used that model. So please, it's important for you to go out of that mode. Don't use Amos. That's the long and short of what Madam Moraka Faith actually pointed out. Okay, so Famuide, quickly, you have the floor.
Hello, sir. A very quick comment, sir. I propose the objective of this presentation is such that we can see that there is the easy way, so that people don't go through this long route.
No, which one is long route? No, hold on. Which one is easier, to use Amos or not to use Amos? You say it's longer route.
Amos.
Amos is
No,
what?
I said Amos is better. Is the best for this.
So why do you have to go for the second best? Why do you have to use your hand to carry the feces, whereas you have a hoe that can let you carry take that, do the task? No, that's the long and short of it. Oh, don't worry, Johnson. You're very fine. You are right. You can any day use multiple regression to do path analysis, but you now have the analysis of moment structures and some other tools that can let you do it better. So don't let's be going back in time. Let's be advancing with contemporary development. So that I think is the long and short of all the questions that have been asked here. Let me thank you all. We let's see how long we have spent. Let me look at my. Okay, we are done 20 minutes after 10. We started at 9, almost an hour and a half, but I've enjoyed every minute of the presentation from Moraka Faith to Dr. Alabi and to Johnson Famuide. It's been quite wonderful. I applaud this class again. I appreciate you. You can see that Madam Fulayo I know has a big smile on her face there. Can you see yourselves though?
Exactly.
Yeah, she has a nice big smile. You can see Fakule is very serious and looking unhappy. So Fakule, if you are going to be happy in this class, you got to put on some good picture. I'm just joking though. You can keep your picture as much as well as you want, but it would be nice to show that you are enjoying the class by putting. Gbeleyi is also okay. A little smile will do though, but his suit is intimidating. Yeah. Wonderful. So let me thank you again. Tomorrow, who are those that are presenting? Captain.
Tomorrow is Ayenowo.
Ayinowo, yes.
Moraka, Aino, and Shaibu.
Wonderful. Now,
One of them will be presenting Amos.
pardon? Oh, they all be presenting Amos. That's very nice. Oh, that's very nice. So, Omoraka Faith, we only need to tweak our presentation slightly. Is that not so, ma'am?
Yes, sir. Yes, sir.
That's very good. And I can't wait to hear Dr. Fumlayo make our presentation. The other two people have not been regular in class, so I'm not too sure whether they'll be able to join us. But I'm confident that we're going to have two very nice presentations tomorrow, one by Moraka Faith and one by Fumlayo Aino. The other two people, if they're able to join us, that's fine. But please transmit the message across to others that we will be glad if they have some internet service that will be a little bit quiet, that will not cause too much of noise, and that if anybody is interrupting, they will have to drop them off. But maybe let me ask you this question. Do you like a class where all of us are present and it's noisy all around? Or a class like this, no, hold on. Or a class like this where somebody who has a bad service is taking off for the present class. Which one do you prefer?
A noise-free class, sir, even if we are very few.
Exactly. You can see how clear this one is. By the time we do a video and put it online, I mean, it's very clear. This is very, very clear. So tell the others that we dropped out that they had, unfortunately, connection that wasn't too good, that was noisy. I trust that by tomorrow we're going to have a better deal with those who are not in class today. Once again, thank you for attending the class. We're 8, including me, that's 9 people in class, which is not too bad. So until tomorrow, dear doctors, I wish you a nice evening. Bye-bye.
Sir, hello, sir. I want to ask for permission, sir.
Pardon?
Hello, sir.
Yes?
I want to ask for permission, sir. Can I bring
Okay, class, so let me sign off for now again. Tomorrow being Larry's birthday, we wish him well. That's June what? 25. June 25 is going to be a great day. June 25, 2017. So we are looking forward to celebrating with you tomorrow in class at 9 p.m. So until tomorrow, class, it is bye-bye.
Good night.
Good night. Thank you. Bye-bye. Bye-bye. Thank you. God bless you. Thank you.